Okay, we're going to start a new section here of the notes, synchronization. This will be page 1, and this is really the heart of concurrent programming. We are going to start this whole discussion by talking about semaphores. Synchronization means synchronizing in time, and semaphores are a tool that let different tasks synchronize with each other. And this is covered in the text in section 9.5. So semaphores were created or first described by a computer scientist named Edsger Dijkstra. And I always have to double check that spelling. He's known for a couple things, but this is probably the biggest one. Now, semaphores, originally these were flags that were used to signal between ships. The name is fitting because instead of signaling between ships, we're signaling between tasks. And a semaphore is a clever, simple tool for doing that. So a semaphore is a counter with 3 functions. So number 1 is initialization. So this will initialize counter value S. So the counter has a value, let's call it S, and it's going to initialize that. The next function is wait, and this can have various names depending on the implementation. So I think sometimes release is another name that's used for this, but wait is more descriptive. So what wait does is it tries to decrement the counter by 1. If it cannot decrement the counter because it's already at 0, then it blocks the task. So try to decrement, block if S equals 0. And the third function is signal. And this one's pretty straightforward. It increments the counter. Say semaphore has a value of 0. One task can wait on that semaphore and it's going to block. Another task, when it's done something, it can signal that semaphore, increase its count, and that will then unblock the first task that was waiting on the semaphore. And so that allows you to synchronize between those 2 tasks. And we're going to look at some use cases of those on the next page.